previous to this unit, we discussed all the background information about creating IT security policy. We talked about the different types of documents, how those different types of documents fit together, how we make the framework of our IT security policy. But up until now, we didn't really discuss anything in detail. We didn't specifically talk about all these specific policies. So starting this week in this unit, we get into more detail. We start talking about specific policies and how you might apply those policies and give you some specific ideas about what kinds of policies you need throughout an IT infrastructure. Unlike the other units, I'm going to give you a quick overview of what we're going to discuss in this unit, just so you have some context as to what we're going to go over. So here's the things we're going to talk about. We're going to talk about the reasons for governing users with policies. In governing, meaning, why do we make them follow the rules, basically. Talk about different types of users. What is an acceptable use policy and a privilege level access agreement. So we're going to discuss those documents and how they can help secure your network and help you in the user domain. We're going to talk about a security awareness policy and why you would have that, what kinds of things you would do with a security awareness policy, the difference between public and private user domain policies. So again, lots of stuff about the user domain. And then we're going to talk about, so after we're done talking about all the user domain stuff, we're also going to talk about the elements of infrastructure security policy. So infrastructure is all the stuff that's not our users. So, I talked about the 7 domains of a IT infrastructure. So we start on the left with users. We're going to talk more about that again, and I'll talk about specific policies throughout that infrastructure. So a lot of stuff to cover in this unit. And then we cover policies associated with the various domains of a typical IT infrastructure, so we'll go over some of the specifics, and best practices in creating and maintaining IT policies in the user and infrastructure domains. So I would say that of all the units that we cover in this course, this is probably the pivot point for the whole course, because before we talked about all of the minutia of developing these policies, but now we're going to get into much more detail about the specific things we can do. And, really, for most of us, this portion of this course is probably feels the most comfortable to us, because most of us are very practical in IT. And all of the stuff that we talk about in this unit is very practical. Before we were talking about business and risk and, these documents that really don't speak directly to technology. But now we're going to be talking about specific technology and how we manage that and how we manage risk with all that. So I think it makes a little bit more sense than what we were talking about before. So let's talk about the actual security policy documents. We've talked about these before. So just to refresh your memory from the previous unit, when we talked about in Unit 4, these different documents, we started with control standards, which are policy statements concerned with core requirements. So the control standard is, we already know what a policy is. The policy we talked about in the previous unit was, here's what I want to happen. Here's my goals. And then the control standard is basically the core requirements to meet that goal. And then we have baseline standards, which talk about specific technologies that we can use to reach that goal, or how to address those goals on specific technologies. And for each baseline standard, you must have a process, so some way to implement that baseline standard. And then finally, you've got guidelines, which are recommendations around those standards. So again, we already talked about this in the previous unit, just a refresher. So throughout the semester, I keep coming back to the 7 domains. So we'll review these again real quick. We started with the user domain on the left, and then we talked about the workstation domain, which is all the devices that our users interact with. And then we have our LAN domain, which is the communication mechanism in our within our organization, and that might interface with the LAN-WAN domain, which is basically what connects our internal network to our to the outside world, which we call the WAN domain. And then 2 other domains that interface with the LAN-WAN domain would be remote access, which would be our remote users, and the server and application domain, which might reside in the DMZ, which again is part of our LAN-WAN domain. So in this unit, we're going to break this up into 2 parts. We're going to talk about the user domain separately from all the other domains. So I'm going to start off, I'm going to talk about workstation, LAN, server, application, LAN, WAN, remote access, and WAN. And then when we're done talking about all that and all the concerns with those things, and some examples of control standards, baseline standards, and so forth and so on, then I'll talk more about the user domain, which is where we'll talk things like the security awareness training and things like that. So this is kind of how we're going to approach this unit. So I'm going to break it up into these two parts: the infrastructure side on the right, starting with Workstation, and then towards the end I'll circle back and we'll talk more about users. So why do we care about all these controls in the infrastructure domain, or these 6 different infrastructure domains? We'll talk about users later on, but it's important to have controls. With a lack of controls, all of the following are possible, and these are from your textbook. Workstations could have different configurations, which is obviously a management problem. So you get this sort of drift over time. You might mint all these computers in the IT department that all have exactly the same configuration, but when they get out into the field without some kind of controls, all those workstations can end up being completely different in time, which of course makes things a lot more difficult for IT. There are certainly some arguments for allowing some of those changes, and we can talk about some of those, but by and large, you usually want to have some consistent workstation configurations. LANs would allow unauthorized traffic, like listening to internet radio, if that's something you don't want people to do for certain reasons on certain networks. So quality of service can be affected, which again, availability is really important to us in IT security. WANs would have vulnerabilities. Our network devices would not be configured the same. So again, you get that drift over time between all these different devices. And you might have a tendency at this point to say, well, wait a second, if I've got all these routers and switches and they're all configured the same way in the IT department, how is it that, that eventually we're going to have this drift of all these different devices? And, the reason for that is, one of the things that controls do for us is it tells us how things are supposed to work. The policy sets the tone, the baseline, the control standards tell us what we should have to meet those policy goals. And our baseline standards tell us how we're going to implement those on specific technology, and then our procedures tell us how to do that. And if you have all that stuff documented, every single time somebody touches or deploys a network device, they're going to have some document to rely on. They're going to have something to fall back on. So you'll avoid that drift over time between different systems. I think if you take 2 or 3 network administrators, even if they work closely together, and each one is deploying network switches on their own without some kind of documentation, I think you would very easily have minor differences between those systems. So having all that stuff documented is certainly important. And without control standards, users would have access to data that they're not directly working with, which is an IT security risk. We don't want people being able to access data that they don't need access to for a variety of reasons. So we'll start with the workstation domain. So our workstation domain is any device for the end user. So in our example, we got laptops, desktops, mobile devices. So anything that the user interacts with would be considered a workstation. At least any IT device, any information technology device would be a workstation. So some control standards examples: we have device management, user permissions, and so forth. So I'll expand on these just a little bit. So one thing we might have, one type of control standard might be access control for portable and mobile systems. So this would establish some kind of restrictions for devices that employees own. So that you would find in the workstation domain. So users that bring in their own iPhone or their own tablet or devices like that, you might write control standards that deal with those devices, and likewise have baseline standards. So acquisitions, you might talk about standards that include minimum hardware specifications, maybe some kind of encryption that's required on the workstation level. So maybe BitLocker on the hard drives and things like that. Configuration management control, so maybe some policies dealing with and controls for dealing with changes to the workstation, configuration, patch management, device identification control standards. So you could write a control standard that talks about how you would identify each device. On a small network, device identification is easy. You just make up a name, Sam's computer, John's computer, sales computer, so forth and so on. But in a large organization, more than 100 people, it's possible that you'll have enough devices that there might be more than one John. So if you name two computers John, they'll have the same name. So you might have some sort of control standard that defines how you're going to name all these devices on the network. You might have control standards dealing with how to lock sessions, dealing with the use of software on workstations, dealing with, as far as software use, things like what your users are allowed to install. And you can have control standards that say that users should not be able to install anything they want on the computer, or they shouldn't be able to install software that isn't digitally signed or from certain places, or it has to come from an FTP server somewhere internally or something like that. Notifications for the use of a system. Unsuccessful logon attempts, that would be an example of a workstation control standard. So some baseline standards that you might find. Let me just click over here. So these are specific technology requirements for each device. So the baseline standard is going to tell you how to implement the control standards on specific systems. So when we talk about, say, the ability to install software, we might have a baseline standard talks about how we're going to, or how we can implement that control standard in, say, a Microsoft Windows environment. And then we might have something about how we can address that in the Linux environment, if that's something that's common. And you may even have that for Mac, for people that have, their iPads and their tablets. And of course, Linux might fall under the Android devices, things like that. Or you can blanket those under your BYOD policy. So some examples would be like host hardening. So you might have baseline standards that talk about, what you would do, what kind of hardening you expect. So in other words, you can have a control standard that says we require antivirus, or we require, that the CD-ROMs don't auto run. And then you can have baseline standards that say, we're going to turn on, the options in Windows that do that, or, something like that. Virus scanner configuration standards, patch management standards, all that stuff would be under baseline. And again, so baseline is addressing specific technology. And under procedures, you're just going to have step-by-step configuration instructions for all this stuff. So you might have procedures on how to deploy a workstation. And that would address the baseline standard for new workstation deployments with hardening of these workstations and things like that. And then finally, you have guidelines, which one example from our textbook that they talk about is preferred vendors. So you might have a guideline that says we prefer Dell, or we prefer Hewlett-Packard for workstation deployments, and here are some here's some basic specs that we always go with for HP. So if somebody's going to order a new computer, instead of having to pour through the procedures and baseline standards and control standards, the guideline might say, hey, we've already done the work for you. Here's a workstation that you could order, or a stock number from Dell or HP or something like that we know meets our standards. And then, folks don't have to think so hard about, what to order. Now, again, it's a guideline, so that might be that might not be something that they have to do. You wouldn't say that you have to order this specific model of Dell, but you would say, hey, if you order this one, then you're going to be compliant. You don't have to worry about all the other standards. But if for some reason they can't use that specific stock number, then they could go back and look at the procedures and the standards and the control standards and say, okay, let me find something that's going to meet these requirements. So the next thing part we're going to talk about is the LAN domain. So in the LAN domain, let me just look at my notes here. So we have some control standards. Oh, by the way, the LAN is going to be servers and network infrastructure, local area infrastructure, so switches, hubs. I don't know who uses hubs anymore, but you get the idea. Even wireless hubs, or wireless routers. So anything that deals with the infrastructure of moving data around our internal network would be in the LAN domain. So even things like your Active Directory servers would fall in the LAN domain, or an LDAP server if you're in the Linux world. So some control standards, we might talk about our firewalls, talk about denial of service. I'll give you some more examples of control standards. Audit events, describing important events that must be audited and reported, such as breaches to routers, firewalls, and servers. Configuration change control, controlled maintenance, controls over media. In other words, what type of media is allowed on the network or on the excuse me, on the local area network. Again, just like the workstation domain, you might have device identification and authentication. So, only certain wireless routers are allowed on the network. You have to, somebody can't just put their own rogue wireless router in place. That might be your policy, that any wireless router has to be approved, or it has to meet the standards or something like that. So somebody can't just put in their department their own wireless router because they don't like, having to put in their, the web key or something. So they're just going to plug one into a network jack and start using it. So you might have a policy that says you can't do that. And you might have some control standards that automate that process. So lots of examples in Table 10-2 in the textbook. And if you're looking at my edition, it's on page 241. But some different control standards. And then for baseline standards, again, this is just like all the other ones. These are specific technology requirements for each device. So you can look at standards from vendors and other organizations. So, for example, Cisco or something like that might already have some baseline standards that you can use to implement some of those control standards. So, some examples of baseline standards from your textbook for configuration is perhaps a Wi-Fi access point security standard, which defines how to set up a Wi-Fi access point. Maybe an intrusion detection or prevention system standard, which talks about how to set up IDS and IPS systems. Baseline operating system configurations for network devices, a standard for remote maintenance and things like that. Firewall baseline security standards. So, firewall, like anything else, you have to document what it's supposed to do. So a baseline standard might be listing all of the rules. A baseline standard for, say, a Cisco firewall might say that it should block traffic, on port 25 or something like that, so it can't pass through SMTP traffic or something from any workstation in the network. Maybe it only can come from the mail server or something like that. So those would be examples of control and baseline standards. And just like everything else, the procedures are step-by-step configuration instructions for specific types of technology. So for every baseline standard you have, likewise, you're going to have a procedure that describes how to implement that baseline standard. And like everything else, you've got acquisition guidelines. So if you, just like in the workstation domain, if you're purchasing a network switch, you could say, here are some network switches that we know are going to be capable of meeting the control standards. So you could list those for someone so they don't have to go through the standards and try to marry them up to the specifications from a vendor. So you could say, here, we have already done the work for you. But again, it's a guideline. Somebody may choose to purchase something different or use something different for some reason. Maybe they need some additional features, so they could go back to the real standard to identify if it's going to meet the standard. So next, we're going to talk about the LAN-WAN domain, also known as the DMZ, would probably be in the LAN-WAN domain. And that's what we were talking about before. So connects the LAN to the outside network, example, the internet. So focuses on securing resources that bridge internal and external networks. So again, this is probably a lot of infrastructure that we would normally call the DMZ, the demilitarized zone, which we talked about before. So some control standards could talk about access control to the internet. So maybe you want to keep users from accessing certain websites. Keep users from accessing certain ports, things like that. You can filter traffic. So baseline standards would be how to implement those control standards on baseline or on specific technology on those perimeter devices. And of course, step-by-step is how to do that step-by-step, which in some cases, I don't think you would get that granular. So you wouldn't say on this specific model of a Cisco router, here are the, here's the actual access control list. You don't have to go to that level of detail. But you could list what those access control rules would be, or what IP tables entries you might have in other routers, something like that. And then, of course, you've got some guidelines, just like everything else. A guideline might say that we should have a DMZ. We should be implementing IDS and IPS and content filtering and things like that. So for content filtering, the guideline might say that that we, maybe a list of sites that we should block. Could be guidelines. The policy might say something like, we don't want users accessing explicit websites, and the guidelines might say, here are IP addresses of known explicit websites that we can just, out of hand, we can block these because we know that, users should not be accessing those. And then that gets you a little a couple steps closer to compliance with your control standard. Again, guidelines. It's something that you don't have to implement, but it's something that's that's recommended, or it's an interpretation of the standard for you. So the WAN domain, we've got this is obviously the public internet. So everything that's out on the internet is on the WAN domain, and of course we don't have much control over the WAN domain. I would argue probably we have more control than the user domain, but not a whole lot of control. At least we can try to protect ourselves from things out in the WAN domain. So in your control standards, you might talk about WAN management, domain name services, router security protocols, web services. I added a couple others here, encryption and SLAs. So for example, we might, to expand on some of this a little bit, so for encryption, for example, you might have a control standard that says whenever possible, users accessing the internet should be using an SSL encrypted website to try to protect information as much as possible. So for example, if, again, I work in the hospital industry and or in healthcare, and we might have a control standard in a hospital that says that doctors that are entering patient data on a third-party website should ensure that they're using HTTPS. So you might be able to that might be your policy, and then you can have control standards that try to enforce that encryption somehow. SLAs. So in your control standard, you might lay out, in your policy, you might have an SLA, and in your control standards, you might have methods or information about how to obtain those SLAs or what to do when there's downtime and things like that. So again, in their baseline standards, we're going to try to implement those control standards on specific technology, and then list step-by-step configuration of all this equipment that's in our WAN domain or that interfaces with the WAN domain. And our book also talks about change management procedures in the WAN domain. And like everything else, we've got guidelines. So, for example, when and how web services may be used is something from our textbook. I think our textbook kind of misuses the term web services a little bit, but I won't get into exactly what that is here. But take it with a grain of salt when they talk about web services in the textbook. And then they also talk about DNS management within the LAN and WAN environment. So, and again, DNS is one of those things that it might be controlled one way in the LAN environment, but it's going to be a little bit different on the WAN side. So we might have things like proxy servers in our LAN WAN domain to manage that type of thing. But again, we could have guidelines on how to handle that. So for example, for DNS, you could have a guideline that says use Google DNS because it almost never goes down, or don't use Google DNS because there's this other DNS that you have more control over, or something like that. So again, guidelines, not stuff we have to follow, but recommendations to implement those policies and standards. For the remote access domain, so the remote access, again, this is our end users getting remote access to our network. And like it says on the right, we focus on authentication and connecting to our local area network. So the control standards might talk about using VPNs, multi-factor authentication. So these are two great examples of control standards. So we might have one control standard that requires the use of a virtual private network to connect from home or connect from on the road for a remote worker. And we might also require that when connecting remotely, we might require multi-factor authentication. So, when for workers that are, or users that are on location, we kind of have a little bit more security there because they have to enter the building. So there may be a layer of security there. It's difficult to get into areas where you can access workstations that are on the network unless you're an employee. But when someone's on the road, if somebody were to steal a laptop and dial up the VPN, how do we know they really are who they say they are? Their credentials could have been cached in the workstation. So you might require multi-factor authentication to mitigate that. So that might be a control standard that you require multi-factor authentication, like a smart card or a key fob or something like that. So under baseline standards, you would talk specifically about VPN technology that you can use. So you could say that that we're going to use Cisco VPN software or some kind of SSL gateway like Citrix or something like that. You could talk about the different VPN client options. You could talk specifically about different multi-factor authentication options like RSA keys and things like that. And then for procedures, we talk step by step about how to configure all this stuff. So great example of a procedure for remote access domain would be step by step how to configure the VPN client. So, and that, that right there is a useful document, because anybody who's going to connect from home or connect from on the road is going to need to know how to set up the VPN, whether it's a Cisco VPN or, connecting with Citrix or using a Windows VPN, whatever it is. It's usually a little more complicated than just using a password. They usually have to put in an IP address or a host name. They might have to get a digital certificate, or they have to get some steps to walk through signing a certificate. You may require that users set it up so that they have to use when connected to the VPN, they have to use the default gateway within the VPN tunnel. That way all their traffic is protected, and so forth and so on, just as if they're sitting in front of a computer at the business or at the bricks and mortar location. And last, of course, we have guidelines like everything else, which could be something like a description of threats. And again, they can be rather generic, these guidelines, or specific, like I talked about with workstations, where we say here's a specific workstation that we approve. Security of remote computing environments. So you might put out some guidelines for users that say, if you're going to connect from home, it's not a work computer. We don't have much control over it, but here's some guidelines. It should be Windows 7 or newer, or Windows 8 or newer, or whatever the latest version of Windows is. Maybe by the time you're listening to this is Windows 9, who knows. You might tell them that they should have their computer patched, that they should have an antivirus. If they're at a Starbucks, to be alert that, be aware of things like man-in-the-middle attacks or something like that. Or, that they're using, encourage people to maybe use a Wi-Fi, their own Wi-Fi hotspot, like on a cell phone or something like that, instead of a public internet. Finally, the system and application domain. This is the last one. So this is really the heart of IT. The kind of the central of IT, what we think of as our data center. So data processing and storage technology. So this will focus on security issues associated with applications and data. So this would be our database servers, our web servers, our email servers. All that infrastructure that's in our typically in our data centers. Our virtualization, nowadays virtualization is all the rage. So it could be our virtual environment. It might include SANs and blade servers and things like that. So some control standards might talk about firewalls around those application systems, and those firewalls could be host-based or they could be network-based firewalls. How to mitigate denial of service, align with functional responsibilities. That's on a bunch of these slides, but control standards have to align with what that software or what that domain object is supposed to do, or what its requirements are. So some baseline standards, again, specific technology requirements for each device. So we might talk about a host-based firewall that we require on each Windows-based server, or maybe some basic IP tables configurations on every Linux-based server. Just some basic stuff to try to protect those. And again, it goes back to defense in depth, these different layers of defense in network security. And we might review standards from vendors and other organizations. And of course, we're going to have procedures, which are step-by-step configuration for each of those specific technologies. So we keep going back to this. Control standard is how we're going to enforce or implement the policy. The baseline standards is specific technologies that we can use to do that, and our procedures are the how to do that. And then finally, some guidelines. And again, we're back to one example being preferred vendors. So just like workstations, we could have preferred vendors. In the system and application domain, we might have preferred vendors for servers, for firewalls, for network switches, and so forth and so on. And this is a big deal because, as somebody who frequently has to talk to IT departments about acquiring new servers for vendor solutions, in many cases, I'm, one of the first hurdles we have to get through is, well, what's your requirements? What kind of server are we going to buy? And it's a lot easier to deal with organizations that have these procedures and guidelines, because they can go to the guidelines and say, here's a list of 5 servers that we know meet our requirements. Pick one. and then I can look at those and I can say, okay, well, this is one that also meets our requirements. So there's some overlap there. That's the one you can purchase. Other organizations say, yeah, give us a list of what you recommend, and we'll see which one. We'll compare it to what our requirements are and see what we fall on. So that can be a little bit more difficult to deal with, but it's certainly good to have all that stuff. And again, you can get to those guidelines by thinking about your policy and then your control standards and baseline standards. And when you define all that stuff, you can develop some guidelines to help people comply with all that stuff that you determined. So that concludes all of the infrastructure policies, and I ran through that rather quickly, but your book is pretty thorough and has a lot of tables that give you some ideas on different policies that you would consider. But next we're going to talk about the user domain. So the user domain is obviously a lot different than everything else we talked about. Technology is very easy to control. I think all of us know how we can, that we can set up technology to do things. We can configure it to do things. And when you tell a firewall to block all traffic leaving the network on port 25, the firewall doesn't usually mess that up, right? The firewall always knows to block that traffic on port 25. And it's, so when you configure these devices, you've got a pretty high level of certainty that that control standard is going to be implemented. As long as the procedures are correct and the technology is accurate. Technology doesn't get lazy. Technology doesn't decide one day that it's not going to work and do something. Although sometimes it seems like that, right? That technology decides one day that, hey, I'm going to break today. But by and large, technology is either it works or it doesn't work. It doesn't have feelings. It doesn't fall for tricks. None of these problems that we have in the user domain. Humans are a little more flawed in some sense. And what's funny is IT people, sometimes I think we really think that way, but from a technology perspective, humans are much less predictable than our technology. So that presents some additional challenges in the user domain. People that use computers have different skill levels. So they have different perceptions on information technology. You can't count on, when you buy a bunch of firewalls or routers or workstations, they all have exactly the same specifications. People don't come with the same specifications. People are all very different and have different levels of understanding of how things work. And, my favorite thing with this area is, again, I work in hospitals, and, I'll watch a nurse, I'll walk up to a nurse working at a workstation, and my task might be to work with that nurse to show them how to use some piece of information technology to access information that she needs access to, or nurses can be guys too, and show them how to do something. And the first thing they'll do is close their Facebook, their stock trades, and their email, and then they'll bring up the application that we're going to work with, and then they'll say to me, I don't really know much about computers. I'm not very good with computers. And so here's a person that just closed their email, they trade stock online, and they're using Facebook all day, and they have to use a computer all day for work, for everything they do, and they've been working there for 10 years, and they tell me, I don't know much about computers. So I think people even have perceptions of themselves that may not be entirely accurate, and I think people do try to use that as an excuse. Social engineering can occur at any time within any organization, so I'm sure all of you are familiar with social engineering, and it's basically when people get tricked into doing something that they shouldn't do. So, a classic example now is these fake tech support companies now that will call you and say, hi, this is John from tech support, and I need access to your computer because we have a very important patch to install, or we're detecting traffic from your computer that's suspicious or something like that. They make them sound legitimate, and then they trick the user into giving them remote access to their computer so that they can get access to the network. And in most cases, they're encrypting all of your files and then demanding some kind of ransom to get your files back. And and it's surprising how many people fall for that. Somebody just fell for this in my office not long ago. We have a very small company, very few employees, and somebody clicked in an email, and and all their files got encrypted, and it asked them to pay a ransom. And of course, we had all that stuff backed up, so it wasn't a big deal. But it's surprising that even in such a small organization, even though we warn people not to do that stuff, it still happens. So it's a major threat, and I would say that's one of the biggest threats that we face in IT security. Human mistakes often occur and lead to security breaches. So people, walk away from a workstation without locking it, or they click on a link in an email that they shouldn't have. One of the most significant threats come from within an organization. So far, we've talked about mostly humans, not acting maliciously, but just, not correctly. But now, we talk about some malicious things. So, of course, a router doesn't act maliciously. A router doesn't have hard feelings against the organization. They're not going to try to steal something. But humans, of course, are going to do this. And I think one of the things in your textbook it says is that that of all the security breaches in the last 15 years or something like that, something like 30% of them were perpetrated by insiders. So certainly is a pretty big threat, that insider threat. So we do have to be cognizant of that and have policies that try to mitigate that. Applications have weaknesses that are not known, and these weaknesses can be exploited by users either knowingly or unknowingly. So we can have weaknesses in applications. So we want to try to, again, we talk about this layering approach. If users know they're not supposed to do something, maybe that will help kind of steer them in the right direction, point their nose in the right direction to not try to do the wrong thing with applications that might allow them to do something stupid or something wrong or something illegal and so forth. We talk about security awareness training that hopefully can remove this weak link in the security chain. So like I said, the user domain, users are our weakest link in IT security. I think we all know that. And again, we're going to talk about ways to mitigate that. Obviously, policies are a great way to mitigate a lot of these risks, but if people don't follow the policies, then they're for naught. So to try to get people to follow these policies, we'll talk about several different ways that we can do that, and awareness training, of course, is one of them. So there's a couple different types of users that we'll find on our networks, and as we write security policy, we have to be aware of and think about these different types of users. The first would be employees, and obviously these are people that work within the organization, and they're people that are using this technology constantly. And then we have system administrators, which are responsible for administering those systems that our general employees use. So, it's mostly IT people. Security personnel, which are responsible for securing those endpoints. And then contractors, which are usually folks that are not part of the organization but need access to those systems. Then auditors or guests and general public. So everyone that resides outside our organization that's not using these systems but somehow interacts with those systems. And I think it's important to notice that, employees, I think, is where we have the most control. And then guests and general public, we have the least control. So, of course, it's obviously why we have the most control with employees. They have very specific rules. We can set up specific rules that, specific controls to prevent employees from doing certain things. We can have very specific access control for employees. Those access controls fall apart a little bit when we move out to the system administrators and security personnel. They may need more access than we can really control. So system administrators, need control over everything. And then contractors, we have control over them from a technological perspective, but not so much from a personnel perspective. So contractors are temporary. They have less incentive to follow our rules, so we have very little control in that respect. But again, we can use more technology controls, similar controls that we might have for employees. And then the most difficult, of course, is everyone in that outer ring, which we have very little or no control. So guests and general public have absolutely no reason to follow our policies. So we can't really assume that they're going to follow our policies. Again, I work in hospitals, and the guests or general public would fall as under the category of patients. And one of the things now that everybody likes to do is give patients access to the internet from their rooms. And one of the important things that all hospitals should make sure is that the network that those guests and those general public or the patients are using is completely separate from the hospital's business side, the clinical side of the network. So you wouldn't want a patient stumbling into medical records or something like that, or being able to find those networks. I have to admit I've been a patient a few times in hospitals, and sometimes I get curious to see, what's available on the network and how well they've cordoned off the network that I as a patient am on, and I've been pleasantly surprised to find that they do a pretty good job in most cases. But I have been to facilities where they don't do that, where there are very little technical controls. I was in an imaging center doing some consulting work, and I found that from the waiting room, you could connect to their guest network, and I was able to access all their clinical systems. I was able to get all the way into a CT, a CAT scan machine, and get a command prompt. So literally from the waiting room, you can shut down the CAT scan machine. Of course, you'd have to have the password for it, but they're pretty easy to guess in some cases, and they're all the same. If you know one vendor's password, you can guess that on every single device, because most people don't change them. So again, we don't have very much control, and there's nothing to stop a person in the waiting room from doing that. Obviously, somebody who works for that imaging center is not going to purposely shut down a CAT scan machine, but some patient in the waiting room that has no incentive not to do that, we wouldn't want to give them even the possibility of seeing that stuff. So more technical controls on those outer ring users, but we have very few policy controls in relation to behavioral things. So just to kind of summarize for you, users require different types of access. They require information from different systems, and data has different security controls. So thinking more about types of users, our textbook talks about this concept of types of users. Just to give you a real-world example, if you have, for example, a senior DBA, under a senior DBA, you might have a Microsoft SQL DBA, a DB2 DBA, an Oracle DBA, and then under the Microsoft SQL DBA, you might have a backup operator for SQL and DBA and a DBO group for SQL. So on the top, that middle tier, and then you would have the same types of offshoots from DB2 and Oracle. And now that I'm looking at this, it looks kind of like a stick figure, that drawing. But on the top there, these are all user types, and then our book talks about user subtypes. So the idea here that what they're trying to show you is inheritance, that a backup operator could inherit the user permissions and technical controls and policies that would exist for a Microsoft SQL Server DBA, and they would inherit all of their stuff from the senior DBA. So a senior DBA would have certain levels of permissions and access, and then an MS SQL DBA would have a subset of that, and then the DBO group and the backup operator would have a subset of that in the user subtype. So if it helps to think about users, to kind of break users into these types and subtypes, and you can go a couple levels deep if you wanted to, but it kind of helps, if you think about the major types of users on the network and then the subtypes and and so forth and so on, that this inheritance will help simplify how you define that access control as you develop these user access policies. So next we're going to talk about a security awareness policy. So in a user policy, in the user domain, there's going to be three things that are a little different than the infrastructure domain. Again, we're dealing with humans. We have to constantly remind them. We don't have a lot of control over humans, and maybe that's a good thing in some respects, but humans are unpredictable and all this other stuff that we have to deal with. So we have to take some special precautions with the user domain. So the first thing our book talks about is the security awareness policy, and this addresses basic principles of information security. So you're teaching the users about information security generically. This could be things like understanding what social engineering is. If you tell somebody about social engineering and how it works, that really arms people against social engineering. It makes them think about that. If you if you tell somebody that somebody could pickpocket your wallet on the subway, I think people are going to be more cognizant to protect their wallet when they're on the subway. So same kind of thing in our networks. If we tell people about these basic principles and how IT security works and why we do it, that's certainly a good first step. We talk about awareness of risks and threats, what kinds of risks we face, and what the ramifications of not mitigating those risks are. Dealing with unexpected risks. So we want to give people the tools, or give our users the tools in this security awareness training to, or security awareness policy to think about a risk, even in situations that are not predictable. We should talk about reporting suspicious activity, incidents, and breaches. So users should know that they have a duty to report these things and when it's appropriate to do so. And finally, building a culture that is security and risk aware. So, and I've talked about this before, and we're going to talk about this more when we talk about policy implementation. But what you're trying to do here with security awareness is overall, you're trying to build this culture where people think about risk and think about security. It's always, something that's in the back of their mind. So, and even from, the lowest levels of boots on the ground, people are thinking about the ramifications of what they do. So somebody gets an email from someone they don't recognize, their curiosity doesn't rule them. Instead, they think about, what's the ramification of me opening this email? What's the odds that I can trust who this email came from? Should I click the links? Should I, they're asking me to give them all this information. Do I just trust them? Trying to make people more suspicious of that type of thing. So that certainly goes a long way. Next, we have an acceptable use policy. So an acceptable use policy attempts to protect an organization's computers and network. It addresses password management, so it tells users what types of passwords they need, what kind of how they can handle software licensing, intellectual property, so what types of IP they can take out of the organization, what's expected of them. So, for example, when most of us, when we work somewhere, they tell us, anything that we create while we're at work belongs to the company. Obviously things we create at home certainly don't belong to the company unless we use our company's resources or other intellectual property to develop that type of stuff. It can describe email etiquette, how to deal with level of privacy an individual should expect. So when you're at work, what level of privacy should you expect in your emails? So you might tell someone that, hey, we do have a right to look at all your outbound emails. We're going to search your outbound emails for certain information or to prevent data leakage and things like that. So you could talk about that. And of course, it's a risk not to talk about that stuff and inform employees of these things. We can also talk about the consequences. So basically the enforcement of these policies. So we tell people, here's what's going to happen if you don't comply with these policies, and what and kind of set the tone for how important it is to follow these policies. One thing that acceptable use policy does for us, and some things that I'm leaving off on here are in the acceptable use policy, we might talk about not accessing inappropriate websites, things like that. And with email, what we should and shouldn't say to customers and things like that. Not saying things to the media when we're not supposed to. So a lot of that stuff would be found in acceptable use policies. And one of the things I want to mention that's important about acceptable use policy is the separation of employee from company. So one of the things AUP can do for us is separate the company from the employee from a legal perspective. So I'll give you an example. If, let's say where I work, I download illegal music to my computer. As we all know, if you download illegal music, if you go and steal movies and music on the internet, and I think a lot of us kind of don't think about that as stealing, and really it is stealing. I mean, if you walked into the record store and pulled a CD off the shelf and walked out the front door, that's pretty clearly theft. And a lot of us don't think of downloading music from a website as theft, but in a way it is. It's just harder, I think, for us to wrap our heads around that. And most users don't think of that as theft, but the law does think of that as theft. So if a user in our network is downloading movies from the internet and it gets traced to our company, we get a subpoena saying, hey, you guys were downloading music. If you have an acceptable use policy that says you can't download music and you can't download movies from work because it's not legal, then we could produce that document and say, hey, wait a second, we have a documented policy that says that our employees don't do that. And if somebody did do that, they were not acting on behalf of the company, so you don't have a legal standing to sue the company. You have to find the specific person that downloaded that music. And, they may subpoena us and say, well, you need to tell me who that was or what have you. But it gives us a little separation there. Likewise, you get a letter saying that somebody went to some inappropriate website. certain websites are illegal to look at. I won't get into the details here, but I'm sure you can imagine if we have an acceptable use policy that says you shall not go to those websites, then we have that separation. We can say, okay, we know that John was downloading these explicit images that he's not allowed to, but our policy is that John's not allowed to do that. So John was acting on his own, and we're indemnified from that act. So that type of thing is one thing that's important from a legal perspective for acceptable use policies, and certainly something that shouldn't be minimized. Another document that we could produce, another part of our user domain policies, is the privilege level access agreement. So this acknowledges the risk associated with elevated access in the event the credentials are breached or abused. So the idea here is we've got system administrators and even some people that aren't system administrators that need elevated access to certain resources on the network. And we want to make sure that those folks don't have or that they understand the responsibility that comes with that elevated access. So, I kind of look at this as having, a key to the executive washroom. There's certain responsibilities you have. You get this key that, that you have some responsibility for that. So this is a written agreement between the company and a user that they are being given access to, to something that's more than what other computers might have, or other users might have. So it asks the user to promise to use access only for approved business, so appropriate use of that information. Great example in healthcare is when we give usernames and passwords to an electronic medical record system, users are told that they are only to use those credentials to access patient records for patients that they are treating. It's very difficult. I mean, put yourself in the shoes of a IT administrator in a hospital. You know that you don't want doctors to not access records that aren't their own. But I'll give you a great example. Let's say a doctor, let's say a patient presents at the emergency room and they say they've got chest pain. And the patient says, I was a patient here 6 months ago and I had chest pain. And that ER doctor says, really, I need to look at those records from 6 months ago. But they've never treated that patient. If you've got really strict access control, then that doctor would not be able to access those records unless they go through some bureaucratic process to do so. Well, if you're a patient, you don't want the doctor to have to go through some bureaucratic process to access those records. You just want them to have access to them. And it seems silly that they wouldn't have access to it. So we give a lot of discretion to doctors to say, hey, we're going to give you this unfettered access to medical records. We're not going to limit what you can access, but with great responsibility comes, or with great power comes responsibility. You have to take some responsibility for the records that you access. So we make them aware that they do have access to all this stuff, but they have to do so with some discretion. And that also gives us the freedom later on to say, hey, you access records that you shouldn't have. Great example of that in New Jersey is when the governor a couple of years ago had a car accident up in North Jersey. I think it was Governor, not McGreevey, the one that came after him, Corzine, I think it was, had a car accident. It was pretty bad. He was in critical condition. They flew him to a trauma center, and some of the people that work in the trauma center looked up the governor's medical records so that they could leak it to the press. And when those leaks happened, the hospital went and looked at all of the user accounts that accessed that record that did not have a reason to. So anyone who accessed those records that did not have a reason to access, that wasn't involved in the care of the governor, was let go. They didn't say, okay, which one of you did it? They just said, well, all of you were wrong. You shouldn't have accessed the record. So they just let all of them go. And again, that's a privileged access level agreement or some analog to this would give us the power to do that. So again, we're asking the user to promise not to attempt to hack or breach security. So don't go looking for things that you shouldn't have access to. Ask user to promise to protect any output from these credentials, such as reports, logs, files, and downloads. So don't print out somebody's medical record and leak it to the press like those folks did at that trauma center. Finally, we talk about the development of user policies. This is the penultimate slide here. We're almost done. I know I've got these long slide decks here, but So some of the folks that would be involved in the creation of these policies, this is similar to all the other ones we talked about. You've got the chief financial officer, which would be involved, the chief operating officer, somebody like the vice president of operations or something like that, the information security manager, the IT manager, marketing and sales managers, and so forth and so on, unit manager just generically. So everyone that's basically in management would probably be involved with developing user policies. And one thing our book left off in here is human resources. So HR would probably be heavily involved in these because we're always going to be talking about consequences for not following the policies, and a lot of that goes back to HR, and they can tell you what you're allowed to do and what's appropriate, what are appropriate consequences. And HR in many cases is responsible to enforce a lot of these policies. So if somebody is caught violating the policy, HR is probably notified, and they're the ones that will have to sit down with the employee and say, hey, you were caught doing XYZ, you were going to this explicit website, this is going to go in your employee file or whatever it is, and if you do it 2 more times, you're going to get let go, or whatever it is. So these are the folks that might be involved, and your book talks in more detail about how each one of these would be involved in the development of user policies. So for both user and infrastructure policy implementation, we would have the information security manager would be involved with the implementation. Of course, they would be helping create the policies, application of those policies, alignment with organizational goals. So the IS manager or the CISO, something like that. An IT auditor is responsible for ensuring that the controls are in place. So after you put these policies in place, somebody needs to make sure that they're actually being followed and do some objective measurements to make sure they're being followed. So that would be something like the IT auditor. And then, of course, our boots on the ground again are system and application administrators. So these are the people that are applying the controls to workstation, LAN, WAN, and domains. So where our IS manager is developing these policies, procedures, and guidelines and all that stuff, and our IT auditor might be ensuring that they're being followed through some objective measurement. Our system and application administrators are the ones actually applying those controls to the network or to those different domains. So that's it. So just under an hour. I try to keep these under an hour if I can. Again, if you have any questions moving forward, please feel free to reach out to me. And thank you.